There are 4 different types of crystalline solids. The first one is ionic crystals. Ionic crystals are held together by intramolecular forces. The intramolecular force that they're being held together by are ionic bonds. So in these crystals we have different ions. So in order to identify them, what you want to look for is you want to look for a metal with a nonmetal and polyatomics and or polyatomic ions. What's holding these together so tightly is the electrostatic attraction between the negative anions and the positive cations. Okay. These electrostatic attractive forces are very strong, and that's what makes these crystals hard and gives them really high melting points. The second type of crystals that we're going to talk about are covalent network crystals. These are crystalline structures that are held together by the intramolecular force of, oh, I have an extra force there. Ooh, get rid of that one. Of covalent bonds. So what we're going to look for here is we're going to look for non-metals with another non-metal. There are not a lot of different types of covalent network solids. So usually what you'll see is you'll see single atoms that are bonded covalently together, or you'll see something like carbon or silicon oxides or silicon carbides. Okay. How these are structured is there are a lot of covalent bonds that are extended throughout a whole entire network of atoms. They're almost always hard and brittle, and they're usually non-conductors and have high melting point. For this class here, in order to help you see these a little bit easier, you'll see a little X down below as a subscript, meaning that you can have a large number of those, or something like silicon oxide and then an X, so that you'll know that it can come in multiple sets. Metallic crystals are also held together by a type of intramolecular force, and those are metallic bonds. So when we're looking for metallic crystals, what we're going to see is a metal with another metal. Okay, and it can be the same metal or it can be a different metal. How metallic bonds are formed is by sharing their valence electrons in a sea of valence electrons, where the valence electrons are allowed to move all around all the different metal cores. And so the valence electrons don't really specifically belong to any atom. They belong to the crystal as a whole. Because the electrons are allowed to move freely throughout the entire crystal, they tend to have really good electrical conductivity, and their melting points vary a lot. Covalent molecular crystals are held together by intermolecular forces. So those are our LDF, our dipole-dipole, and our hydrogen bonding. If it's a nonpolar molecule, the only type of IMF that it can have are LDFs, and LDFs tend to be weaker. Polar molecules have LDFs as well, and they also have the stronger forces of dipole-dipole or hydrogen bonding. So if it's a nonpolar molecule, it only has LDFs. It's a polar molecule, it has LDFs and dipole-dipole. And then if it's a polar molecule and it has an HF, an HN, or an HO bond on it, then it's also going to have the hydrogen bonding. Covalent molecular crystals tend to have low melting points and they're easily vaporized, and this is because they're being held together by those weaker intermolecular forces. Remember, your intermolecular forces are weaker than your intramolecular forces.